In this video series, we're going to work through deploying Kubernetes in the cloud. And there's a couple of other series we've done in the past. One is the scaling in the cloud and the simple cloud container series. And in both of those, we took essentially an identical Python-based microservice and deployed them on VMs in the scaling in the cloud or containers with a simple runtime like AWS, that would be App Runner, a Azure Container App, or a Cloud Run under Google. And so what we're going to do is we're going to take that exact same Python microservice and a few other things, and we're going to containerize it and using Docker like we did with the simple cloud container series. But then we're going to use Kubernetes as the runtime. And so for each one of the cloud platforms, AWS, Azure, GCP, we're going to give you a fully automated deployment where we'll build and deploy the following components. So first, the microservice uses a document database, and we use the cloud native one, DynamoDB for AWS, Cosmos DB for Azure, Firestore for GCP. Then what we're going to do is we're going to take that code that we used in the other projects and we're going to build a Docker container out of it. And we're going to also build 3 other containers that are just content. I found these neat games on the internet, which are JavaScript versions of Tetris, Frogger, and Breakout. And what I did is I bundled each one of those as containers. So we end up with 4 actual containers, the microservice, and then these 3 game ones. Then we take all those containers that we've built and we push them into the appropriate container registry for the cloud provider. For Amazon, that's Elastic Container Registry. For Azure, it's Azure Container Registry, and Google Artifact Registry, it's for GCP. Then once we do that, we're going to build a managed cluster. So that's EKS, AKS, and GKE. This takes the longest in the build. It takes usually 15 to 20 minutes to build these clusters. And then we have a series of YAML file manifests that are going to deploy all 4 containers with in different node groups. So there's a node group for the games and there's a node group for the microservice. And we'll apply those, and then we're also using Nginx as a unified ingress controller where we have like one load balancer for the entire thing, but then we have different endpoints on the load balancer, one to hit the API, one to hit the Tetris game, Breakout game, etc. And so that gives us sort of a unified interface into our deployment. So here's the links to all the other solutions, and have a little discussion about the nature of these services. They're billed as platform as a service, but the way it works is these systems deploy infrastructure transparency. So it sort of feels like it's infrastructure as code, but it's supposed to be platform as code. So let's just sort of a platform as a service. Let's go and walk through the elements of these services and kind of understand the infrastructure versus the managed control plane and how it's a little bit different than the other platform as a service options. So let's start with the core part, the managed control plane. Now this is a set of Kubernetes services. We have no insight how they're deployed. They're usually accessed through HTTP endpoints. I assume on our behalf, the cloud providers are provisioning VMs. Maybe it's containerized, but you really don't. It's fully abstracted. You don't know how they're doing it. And we contrast that with once you start building elements like node groups, we start to see the infrastructure as code under the hood. And so for each node group or node pool, because the terminology is a little bit different depending on the cloud provider, it actually implements those with the scaling infrastructure that we covered earlier. So EKS uses auto-scaling groups for each node group. AKS uses virtual machine skets for each node pool, and same with Google Cloud or Google GKE. It uses managed instance groups for each node pool. And so you're not provisioning it, but you give a description of how you want these pods to interact, like nodes, like how they scale, with the min, max, the size, etc. You describe that to the Kubernetes system, and it goes and provisions all this infrastructure for you. which why it is a little confusing is that you transparently can go into the console, and if you don't know EKS is installed or one of the other Kubernetes, you'll just see all this infrastructure, and it's like, well, what's going on? It's because it's provisioning it and making it completely transparent, so you can just see the infrastructure. Now, it is a little bit dangerous because you can go in and actually modify the infrastructure directly and break things, which is not cool, but that's sort of the approach they've taken. And it also gives you the ability to customize things. So if you really need to make a certain change, like on your auto-scaling group to have like a particular, like a common mount point on the node, you could do it. Whereas, if it was fully abstracted, you wouldn't have all those hooks. So that's for the auto-scaling and the nodes. The other piece of infrastructure that you'll see is when you start provisioning service objects with load balancer or Nginx, and Nginx will implement its own load balancer. That's going to call out and provision the infrastructure on the back end. So AWS, you're going to get Elastic Load Balancer. Azure, you're going to get the Azure Load Balancer, and of course the Network Load Balancer with GCP. So you don't configure these directly. Also, most of these are not tied to instances or auto-scaling groups. They're tied to IP addresses because the control plane is going to glue up when the services need to have certain pods talk to certain load balancers. It's going to do it all by IP. So it's not quite the same load balancing configuration that you would see in auto-scaling, but it's very similar. It's just done by IP addresses instead of instances or attached to an auto-scaling or a scaling group. The final part is when you open up the console and you start looking at things, you're going to notice something very interesting. Tagging and labeling in GCP is what's used as bookkeeping to keep all this stuff straight. So if you go look at any of the nodes, the load balancers, the auto-scaling groups, and you click on tags or labels, you're going to see all these tags that it's using to manage its internal state. This also is a bit of a danger area because there's nothing to prevent you since the infrastructure is transparently available to you. You can go in and start messing with these tags and things will stop working. So there's sort of a double-edged sword there. You can heavily customize your infrastructure, but you also can screw it up. So finally, what's the conclusion? Well, it is platform as a service, but the infrastructure provisions, once you describe what you want, you see the infrastructure. Transparently, you can see the infrastructure. That's not abstracted. And so the way I would describe this is, say you're using one of the cloud provider's Active Directory services. Now, those services are obviously spinning up VMs or EC2s with the domain controller and probably other things, but you don't see it. So you just get, the two DNS endpoints, and that logs you in and allows you to hook into joining the nodes. But you don't actually see those EC2 instances, VM instances in the console. It's fully abstracted for you. And same thing with databases like RDS and Azure SQL and whatever it is in GCP. The databases that it provisions, when you say, give me a Postgres server, you're not going to see the servers. And then when you do things like give me a reader, give me a global reader, you're not going to see the infrastructure. You're just going to see the logical endpoints that it provides. So I hope that kind of explains the relationship of platform as service versus infrastructure as service. It is kind of an interesting combination. Okay, let's walk through the solutions and get a feel for which they each look like. And then we'll do a quick demo of, I believe I've deployed AWS for this intro. So let's take a look at the AWS solution. So we have two diagrams for each one. One that describes the logical Kubernetes deployment, and then the second one that describes the infrastructure that gets provisioned. So in our example, we're building in US East 2, and we're deploying an instance of the Elastic Kubernetes, EKS, and you get the control plane. Now this is going to look very similar in all three. They all have a similar control plane. I took some of the services, sort of the top 5 services, but there's many other services in the control plane. But the key is the API server, which we're going to use kubectl to interact with the Kubernetes cluster. So that's the control plane. That's the fully managed abstracted part of EKS. Then we have the two different node groups. Now, in EKS, they actually call it node groups. The other ones call it node pools. But these are the actual nodes where your pods, your containers are going to run. And so what we do in this example is we create two node pools. One is the Flask app node pool where we put the API, and then the second one is the games node pool where we put the game entry points. So you'll be able to look at those individually by node group, and I think we also create a namespace for games that we'll show. So those are where your containers run. And then there's a series of connected services. And so the first one is we're connecting to our VPC. We'll talk about in the video about some of the things you need to worry about with networking. One of the key concerns is the number of IP addresses. It's an IP address by pod, so you got to pick your appropriate CIDR name for your VPC. Then we have an Elastic Container Registry. We end up with two repositories. We have one which is, or two registries, one for Flask app and one for the game nodes. Next, we have the DynamoDB. We're connecting that by a Kubernetes service account, which is connected to an EC2 role, or maybe it's just an IAM role, which allows these Flask apps to interact with the DynamoDB database. Then there's the Elastic Load Balancer. We're provisioning a level 4 load balancer. We'll talk about when we do the AWS specific things. By default, it does a classic load balancer, which is kind of stupid because Elastic Load Balancer hasn't been supported for a number of years. And then we pair that with the Nginx services. So we have the load balancer, and we do the Nginx to do the path routing to have the games go to one endpoint and the API to go to endpoint. So we provision all that. But if you're to go into console, what would you see? And so what you're going to see is you're going to see in our VPC, we have two subnets because that's what you need for auto scaling. And so for the Flask app node, we get the node group, we get an auto scaling group for that. And I think I have 1 to 4 nodes, and we will demo scaling on all of these. Then we have the second one, the games node. And the games node there's only one node, but it doesn't matter because it's still going to manage it with a auto-scaling group. So you'll have a desired min and max to be 111. And we'll talk about in the AWS how you could use Fargate for the second one, but we just did a simple node. Then we have Nginx when it provisions the ingress controller. It also provisions the network load balancer, and that network load balancer, it's a level 4 load balancer that gets created. And it's by IP. So the control plane is going to populate this load balancer with IPs that are going to actually map to actual pod instances. But that's what you'll see. Then we've got the Flask app, container registry, the games, container registry, and then the database. And all those don't exist in the VPC, they exist in the account. And they're region specific. So that is it for AWS. You've got the control plane, and then you've got the infrastructure. So now let's do Azure. So Azure is very similar. You're going to notice that the diagram for the control plane, the Kubernetes instance, is very similar. You've got the control plane. It's got all those services. We connect them through to kubectl. They call it node pool versus node group. Same idea. It's where your containers are actually going to get run on what nodes. And then our connected services are virtual networking. Again, you need to make sure your CIDR block is big enough for all your pods because each one gets its own IP address. We have the Azure Container Registry. It looks a little bit differently. There's one instance of the Container Registry, and then there's sub folders within it that has the games and the Flask app. Then we have the Cosmos DB, same deal, where we provision a Kubernetes account. Then we attach it to a RBAC role into Cosmos DB, so these things can connect to the database and read write. Then we have the Azure Load Balancer, and then Nginx services. Now, one thing that was a little bit strange that we'll get into is the Azure Load Balancer actually ends up provisioning a level 7 load balancer by default, which gives some interesting things with path health check things when we go to Nginx, but we'll cover that in the Azure specific presentation. All right, so let's look at the actual infrastructure. Well, Azure does something that's pretty cool in that it creates this sort of pure resource group. Of course, everything has to be in a resource group in Azure, But when you say, okay, give me this EKS instance in this resource group, it's going to create this peer resource group that provisions all the infrastructure that we've talked about, how it's transparent. So it's a kind of a container, so you can say, oh, that's why this is here. It's just the Kubernetes infrastructure, which makes it a little easier to deal with than the other cloud providers where it's just kind of intermixed with everything else. And so in that, you're going to get two VM scale sets, one for the default node pool, one for the games node pool. Again, there's only one instance, but it doesn't matter. It puts all nodes within VM scale sets. Then we have a public IP address for the load balancer, and then we have that load balancer. It ends up being a level 7 load balancer, so it's an HTTP load balancer, basically an application load balancer. And then we've got the Cosmos DB table, which stores the microservice instance metadata. And then we have the Azure Container Registry. There's just one with different subfolders, one for games and one for Flask app. So that is it for the Azure solution. Now let's go to the GCP. Again, this first diagram is going to look familiar because it's very similar across all of them. Now, of course, Google Cloud is the OG for Kubernetes. They developed it. And just like everything else, everything is easier in Google Cloud, including Kubernetes, which is a lot easier to configure. It's quick to come up, and I think that just is reflective of that they're the pioneers of this technology. So same deal. Got the control plane. We've got kubectl talking to that. They call it node pools. We have a Flask app node pool and a Tetris or a games node pool. Then we have the VPC networking. If you don't do that, it'll actually just put it in a default network. I'm not sure exactly how it works, but I always explicitly create my VPCs. We have an artifact registry. This one's more like AWS in that we have a games registry and we have a Flask app registry. It's a little bit different than Azure, which you have that combined registry. Then we have the Firestore database. We create the access, the Kubernetes account, and then assign the roles to the project that allows it to interact with this Firestore database. Then we've got the load balancer paired with the Nginx services. So that's the Kubernetes view. So now let's look at what you actually see get behind the scenes. So very, very similar to the other ones. You're going to end up with two managed instance groups, one for Flask app nodes. That's going to have worker nodes. It's going to be multiple one. Then we have the managed instance with game nodes. There's only one, but it's still an instance group. Then we have a Nginx provision cloud load balancer, the Firestore table, and then the two registries, the Flask app and the games registry. So let's do a quick demo, and then we'll move on to the actual projects. Okay, let's start with hitting the endpoints. So what I'm going to do is I'm going to go to, I've built Azure, or not Azure, AWS, and I'm going to run, do clear, and I'm going to do validate, make sure it's all running, testing EK solution, there we go. So here is our good to go endpoint. Notice it's the path is Flask API, which is different than the other projects where we just had it at root. So I'm going to take this guy here, I'm going to bring up Postman, and I'll put that in there and hit send, and you're going to get there we go, you get a response. So then I can go and say candidates, and you've got John Smith, and of course you can do a post candidate, do a homie, hit send, that's going to create homie. Now if I go back to get and say candidates, you're going to get homie and John Smith. So that is the API. We've done this many times before, so hopefully if this is not the first time you're seeing this solution. Then we're going to take this guy here, and I'm going to go to the web browser, open a new tab, and in that I'm going to do candidates. I should get the same thing. But what I'm really interested in now is I want to go and say games Tetris. And now I've got Tetris running. Same with Frogger. and the last one is Breakout. So those are the 4 inputs, the games, and then the API endpoints. So that's what you get built at the end. And so let's look at this a little bit. Let's go into here and let's do kubectl get nodes. And I've got 2 nodes, each for different node groups. And so if I do kubectl get pods, you're going to see the API and then the games, and hit games. Yep, hit pods. And you've got the games running. And of course, at this point, I can go and say describe pod paste -in games. And at this point, you're in the Kubernetes world. So if you're familiar with Kubernetes, you know, at this point, you can do all sorts of things. Like I have one here that's stress, which we'll go through, and you run stress, and that's actually going to put more nodes than are available, and actually will scale up into the appropriate number of nodes. So we're going to show this solution end to end, and each one of these solutions is a complete push button install. You can just run it, and it's going to give you a complete Kubernetes deployment with what we've shown in this intro. So with that being said, please join us on the individual videos, and thank you.